This news session. So we'll come to the last late-breaking news of this year's Congress. It will be devoted to the EADS Astrium space tourism project. I think this kind of initiative is quite fascinating. We have all been quite surprised, or let's not say surprised, but we greatly appreciated the success of the Ansari X Prize in 2004, which was won by the Bert Rutten plus Paul Allen team. Definitely we think that this new approach to a new space, let's say, is something quite new, again, and really original, opening a gate to we don't know what yet. Will it fade away completely? Is it just an epiphenomenon? Is it something really serious? Could we imagine that one day every small aero club will have its own little space tourism plane and you'll just fly every day, once an hour, once every 10 minutes? Why not? This is something quite strange because we're not used to have something completely unknown in front of us. Key players have started, mainly, of course, of one major airline company. But today, I think one interesting thing is we have among the key players a key industrial, which is EADS Astrium, and that's quite interesting. Why does a company such as EADS Astrium start an initiative such as this one? Does it mean that really we should give it some kind of credibility? How do they cope between this activity and what I would call real space, under bracket, the orbital one? Is there any synergy? What kind of synergy could we find between these kind of vehicles and the ones that we are used to deal with? So for all this, it's very fun. I'm very pleased to introduce Christophe Chavagnac, who will explain us the approach and give us some details about this plane. So Christophe graduated from University of Lyon in mechanical engineering in '87. Postgraduated after from Von Karman Institute, NATO Research Center in Belgium, in fluid dynamics in '88. And since this, he is in EADS Astrium. Formerly it was Aerospatial, and okay, the names change so quickly it's difficult to keep track. First as a R&D engineer during 10 years in aerodynamics, mission analysis, flight mechanics for various programs such as Ariane 5 and the ATV. Then system engineer during 4 years for the atmospheric re-entry related projects, especially the Pre-X program for CNES in the early 2000 years. And now project manager since then at the business division of launchers, currently project manager and chief engineer for this space tourism project. So please, Christophe, floor is yours. Try to explain us why we should believe in it.
Okay. Works? No, it doesn't work. Okay, thank you, Christophe, for this very positive introduction. Good morning, ladies and gentlemen, and thanks for attending this late-breaking news. So today we'll speak about the EADS Astrium Space Tourism Project, and we'll provide you some details about this project started a few years ago. So the outline of this presentation will first remind you, for most of you probably, what is suborbital space tourism, then a very brief overview of the space tourism activities worldwide today, and we'll focus on the EADS Astrium concept itself, recording first the level 0 system requirements, then the flight profile, some statements about the cabin interior, the competitive advantages of this specific project, and we will then, let's say, get some information about the business standpoint, how we expect to finance the development phase of this program, what can the project bring, especially to the European space business, and finally, what are the next steps in the coming months, coming weeks and months for this project. So, first, just to recall what suborbital space tourism is. It's basically it's basically addressing a mission for reaching 100 kilometers altitude or beyond, or 63 miles for US units, for providing a unique view both on Earth and space, because at this altitude, of course, you're in the black sky for at least 50 or 60 kilometers, and of course to experience some minutes of weightlessness experience. The Space Tourist Service is a package which will include, of course, the return trip for the customer from home to spaceport and back to home for a couple of days. A pre-flight training in a spaceport, a light pre-flight training. There is nothing to do with orbital space tourism, and months of preparation in Star City, for instance, for the ISS and the flights on board the Soyuz. So in that case, it's a very light preparation, combining fitness check, technical briefing, and what the customers will experience during this once in a lifetime trip. Of course, accommodation in a kind of high-end resort and entertainment during the days the customer will be there. And of course, the core part of the package, the space flight itself, lasting roughly 90 minutes, including the space trip. We will see later on a slide describing more in detail the flight profile. About the spaceport itself, excuse me, there are many initiatives running worldwide, and it will be combining, of course, first the location for getting the space trip alive, with the craft taking off and landing from the spaceport itself, together with, of course, training facilities and accommodation as well. And in parallel of that, for beyond the customers itself, we expect to have some occasions and some, let's say, services to general public, combining entertainment or even edutainment with some, let's say, museums or flight simulators to give a feeling to general public what a space trip is, and everything surrounding space activities. A few words about the space tourism activities worldwide. You are probably aware of the fact that regarding the competition, more than 40 projects are running worldwide. At EADS Astrium, we have, of course, identified some credible competitors. You have here the most famous ones, which are Spaceship Two, marketed by Virgin Galactic, and Rocket Plane, which is marketed by Rocket Plane Global. And there are some outsiders, which to the, let's say, the comprehension of EADS Astrium, are less mature and are in the background of the competition. Already said, some heavy investment for spaceports, especially in New Mexico, in the southwest of US, and also in Europe, in the north of Europe, in Kiruna, in Sweden. There are some initiatives running in the world. About the market, you probably know the Futron analysis, which was conducted in 2004, with an update in 2006, showing that 10 years from now, or 10 years from the starting of the operations, up to 15,000 people would be flying on these machines. Of course, inside the EADS Astrium, we conducted an end-to-end marketing analysis for strengthening this data, and our conclusion are even beyond these assumptions, both in terms of trends and volumes. And in addition to that, of course, besides the core target of this project, we could imagine some spin-off missions in scientific missions, for instance, or homeland security or military. From a regulation standpoint, for finishing this slide, FAA in USA has conducted for some years many actions for, let's say, framing the legal and regulation rules for allowing such projects to be, let's say, operated commercially, and to offer to paying customers some insurance with such a service. So now we'll focus on the EADS Astrium concept itself. Here we record, for your comprehension, the major level 0 system requirements. First, for a launcher, for a kind of launcher, we speak first about the payload. A very important payload in that case, the 4 passengers. This project is definitely passenger-centric. It's, of course, the first reason to get this project alive. In terms of performance itself, as already said, we have to reach at least an apogee altitude beyond 100 kilometers or 63 miles. And for that, we have to optimize the vehicle size, its weight, and the engine's power. We will see later on that we have two kinds of engines for powering the vehicle. The cabin design is a very important fact. It's the interface to the passenger, as you do when you fly on a standard airline. So we have to maximize the volume available per passenger side, because we are recording the fact that we are interested in two things when flying on such a craft. We are interested to get very high for getting the view of the Earth, and also to experience weightlessness. So in our case, we decided to get a requirement related to the volume of the cabin itself, to maximizing it for offering free floating in the cabin. Environment friendly, it's a very important aspect from two perspectives, both for safety reasons and also for, let's say, from an environment impact standpoint, to avoid, to minimize the carbon footprint. We are, of course, safety-oriented approach. It's definitely a design to safety vehicle. We expect to get far beyond safety levels recorded for standard launchers, let's say in brackets. Of course, from a business standpoint, we have definitely to lower at the maximum the direct operating cost, the cost incurred during the flights themselves. And finally, to give you a magnitude of the rate we expect to experience during the operations, we have in mind to operate the vehicle one flight per week, per vehicle. So also from a design standpoint, we have to be very careful about the design to operations aspect of this project. So you have already maybe seen this picture on the internet. It's basically a business jet like aircraft in terms of size, in terms of mass at takeoff, carrying 4 passengers and 1 pilot on board. With the wide cabin, we will get some details later on, with wide cabin offering, of course, excellent comfort through the flight, and numerous large windows for getting the amazing view outside the vehicle. 2 business jets, standard aero engines, you see there. The rocket engine on the back of the vehicle, featuring a combination of liquid oxygen and methane propellant that is environment friendly. We will see that on the next slide. Each vehicle is expected to be operated over a 10 years period, and with a pace already mentioned of 1 flight a week, meaning basically 500 missions over the lifetime of the vehicle, which is almost 0 compared to a standard aircraft. It's of course quite challenging for a standard launcher, but it's quite 0 for a standard aircraft. So we are definitely in between 2 worlds, between the aircraft world and the let's say space transportation world. And the development and production activities will be let's say led by EADS Astrium, involving of course some other business units of EADS, especially aircraft manufacturers, and some other industrial partners or labs throughout Europe. What's up? All right. Next now the flight profile. We first start with a takeoff from a standard runway, with getting up the altitude of the vehicle. This let's say time frame is 45 minutes roughly. Then we enter what we call the space ascent gate. We transit from pure aeronautic mode to space mode, with igniting the rocket engine and then cutting off the turbofan. We will check first that the rocket propulsion system is healthy enough before shutting off the turbofans to get a kind of design to safety missions and vehicle as well. After 1 minute and a half, we will shut off the rocket propulsion system, and then after 3G's acceleration, we enter the core part of the mission for the customer, which is the weightlessness period, which will last roughly 3 minutes. Of course, it's a direct relationship with the maximum altitude reached, and depending on the altitude reached, this duration could be let's say enlarged. Then we enter a key part of the mission from a safety standpoint, the descent itself, the space descent itself, aerobraking in the atmosphere because we are only applying gravity field and aerodynamics to the vehicle. The max acceleration endured during this phase is 4.5 Gs. We will see later on that it's not so much big deal depending on the design of the cabin. Then we cross what we call the space descent gate, and then we transit from space mode to aeronautic mode, meaning that we are flying now like an aircraft. Thanks to its higher L over D, we have plenty of time to reignite the turbofans. We have a very low sink rate, and it lasts. We have some minutes in front of us to reignite the aero engine, to check they are all right, and then to ignite them, to go back to the point A, because it's not a point-to-point mission. We expect to take off and land to the same point at the spaceport. So the cabin interior, the core part of the vehicle. What are the drivers for the cabin interiors? First, of course, the marketing aspect. It's an important point for the customers we expect to have on board. We have in mind to, of course, maximize the view outside, and we expect to have a kind of switches. And for my dear colleagues from the design office, it's a pure nightmare to get a cabin with so many windows, because we will face a delta pressure between the outside and inside, which is basically one bar or 100,000 pascal. So from a mechanical standpoint, it's very, very challenging. The seat designs, it's a very specific design aiming at minimizing the head-to-foot accelerations. What is very stressing for our body is accelerations translating from the head to the foot. And now you see on the right side a picture, data from NASA. You see here the acceleration and Y direction and the time in X direction. You see here the loads which are acceptable from head to foot, and here the accelerations, let's say, tolerable from the back to stomach or the other way. And we see, you don't see many well, but you don't see very well maybe. But here we have 5 Gs, and here we have 10 seconds and 1 minute. And you see there, according to the fact that it's written there, we have a hammock-like design seats which rotate freely in the direction of the greatest acceleration. It's a passive system, so from safety standpoint, it's really a positive point. And whatever the acceleration, it's always in the same direction from the back to stomach, and it's definitely an asset for product, because there is no acceleration from head to foot, meaning that at the maximum, of course, it's not the objective, but we could face, according to this figure by NASA, up to 20 Gs for some minutes in this direction. Of course, it's not the purpose to maximize the Gs during this mission, even if customers pay for getting some emotions. We don't want to get to the limit. So it's definitely a key part of the design of this vehicle. And you see here on this picture some different pictures during the timeline of the mission. The position here will be what the customers will during, let's say, the aeronautic phases, both during takeoff and climb and back at the end of the mission. Here, of course, what the passengers will enjoy during the core part of the mission, free floating in the cabin itself, with some traps, and some many windows already explained previously. You see there that we have maximized the volume inside the cabin thanks to this layout of the different seats. You see here the 4 seats, and here other, let's say, strange picture in brackets to give you an understanding of hammock design means. Here we are in the position of rocket ascent, and in that case the seats are rotated roughly 90 degrees to be in the direction of the main acceleration. Yeah, okay. 5 minutes left, all right. So the competitive advantages of this concept. First, from comfort standpoint, already said the cabin and seat specific design, it's definitely an asset. An attractive cabin layout made by the famous designer Mark Newson from Australia. Environment friendly, as already told before. Here, let's say a figure from Boeing, a paper from Boeing showing compared to jet fuel from crude oil used every day on aircraft, compared to different propellants, rocket propellants, and you see there that methane is definitely lower than jet fuel. So we consider that it's an advantage. Safety already mentioned it several times. A safe return to spaceport all over the mission. Descent and landing ensured thanks to the aerodynamic performances of the vehicle. And also, last but not least, it's designed by an experienced aerospace company, merging different competencies in aircraft manufacturing and launchers as well. And last but not least, a low direct operating cost. Business standpoint, assuming a start of development in 2008, we would start the operations in 2012 or so. We have assumed, from business plan standpoint, we will capture 30% of the forecasted space tourist market. It means, in the background, that we expect to be not alone on this market, of course. We have in mind that several operators will be there for offering this service. And we rely on the Fortran market analysis to be on the safe side of this evaluation, because I already said the own evaluation of EADS Astrium is more positive than the Fortran market analysis. But anyway, 15,000 people a year, it means many flights a year, meaning from an industrial standpoint that we will get a continuous production compliant with market volume and growth, both for the vehicles themselves, up to 5 vehicles a year after 5 years of operations. Also for the rocket engines, because we have to change the rocket engine sometimes a year, depending on the pace of the missions. So also a huge volume of rocket to produce, let's say 20 rocket engines a year, which is basically twofold compared to Ariane 5 today. Then just a few words about the organization of this business. We have first the supplier for both the vehicle design and production, and also not to be forgot, of course, the maintenance itself. Then we have the spaceports, where a vehicle operator will operate the fleet of 20 vehicles, I said before, if everything goes well as we expect. The accommodation supplier, which is of course definitely a very different business, with the tour operator, of course the travel agencies for selling the package. How to finance this development? This is innovative from this standpoint as well. We will rely on private funding due to rewarding payback during the commercial operations. We expect to combine pure private financial partners of source and industrial risk-sharing partners, and at first, of course, EADS itself. And we expect also to gather some additional fundings coming from local administration throughout Europe, as Airbus does for new developments. We expect to join the efforts from France, from Germany, from Spain, and possibly some other countries, and also possibly some innovation agencies. What can the project bring? And it will be basically the last slide. It's a credible business growth opportunity with a new funding source first, beside our, let's say, usual customers, which are ESA, CNES, and military procurement French agency. This is the same order of magnitude in terms of, let's say, core business compared to military or civilian core business. It's a regular production activity. It's a very important point from different perspectives. The birth of a new business, for sure, with a new type of vehicle. The growth potential or evolutions of this craft are today unknown, for sure. If we are in the position to fly each week a vehicle featuring a rocket engine and flying without losing money, it will be definitely the birth of a new business, and we cannot say today which kind of step we will get beyond this project. Maybe high-speed transportation, point-to-point, quick access to space, for instance. And of course, last but not least, it's a very important matter from a techniques and technology standpoint. It's the occasion for European space industry to get a step further, Ariane 5, for instance. And it's also a very important point for the space business in Europe. So last but not least, the activities in the remaining months from the end of 2007 and beyond. We are currently extending the external contact thanks to the fact that now this project is public. It's easier to raise some funds for the development of this project. And of course, in prior to that, I'm paid for that. We will refine the program and engineering activities and design, which is running now for some years. And of course, we have in mind to be ready for start the full development itself in 2008. So it's the end of my presentation. Maybe I'll present the movie or not? Yes. Yeah.
Okay, by the way, who wishes to take a ride with him? Raise hands, please. Okay. Okay, do you have your check? Your check slip?
It's a vehicle. It's in the spaceport itself. Here's some pictures of the ATV on the ISS. So of course there are some days of maintenance in between two flights, as low as possible, but anyway some, at least for the rocket propulsion system. Here you see the very specific features of this airplane with a canard-like configuration from aeroship design standpoint, with the many windows on the vehicle. So you see here on the rear the rocket engine. We will take off as a standard aircraft from a runway. First, the first part of the mission to climb to an altitude between 10 and 15 kilometers. Then we will ignite the rocket engine, and the flight path is quite vertical to reach 50-60 kilometers at the end of the rocket phase. Then the cutoff and the core part of the mission with the weightlessness period. The view from outside. And after some minutes, we'll enter the descent, the space descent itself, which will be for sure impressive as well for reaching the ground after roughly 1 hour and a half. Okay, thank you, and we are waiting for your question. Thank you.
Thank you very much, Christophe. It's strange, sometimes I believe it looks very much like a first stage of an LLV that we have been Okay, so we have time just for a couple of short questions. I remind you the rules. Since we are recorded, please state briefly who you are, your organization, and try to make very short questions and very short answers, please. We have on our left.
Hi, I'm Chuck Lauer with Rocket Plane. Do you have any concerns about the free-flying, the zero-gravity